Hi, welcome to Learning Monkey. I am Raghuir. In this class, we'll discuss about composition of functions. In our previous classes, we clearly discussed about the basics of functions. Please watch the classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, first we are going to understand the composition of function operation using an example. At the end, we are going to understand the definition of the composition of functions. Let's take an example. Let f is a function that maps from x to y and g is a function that maps from y to z. Take two functions. The composition g circle f is given as, the composition operation is given using a circle symbol. G circle f is given as g's composition f of x equal to g of f of x for all x belongs to x. So what is this? Let's try to understand with an example. Let's take two functions. F is a function that maps from x to y. G is a function that maps from y to z. And G circle f is the composition of functions. So G of f of x is given as G of f of x for all x belongs to x. What's that mean is, for every x belongs to x means take x1, substitute here. F of x1 is y1. So in place of f of x1, you can place y1. G of y1 is z1. So x1 is mapping to z1 in G composition f of x. So G of f is given as, G circle f is given as x1 is mapping to z1. Similarly, take the next one. For all, you have to do this operation for all the x values. Take x2, substitute here. F of x2 is given as y2. Then G of y2 is given as z2. So x2 is mapped to z2 in G of f. G circle f means G composition f of x. Similarly, take the next one. x3 is substitute here. G of f of x3 is given as, f of x3 is given as y3. G of y3 is given as z3. So x3 is mapped to z3. Similarly, take the next one. Next x is x4. G of f of x4 is given as, f of x4 is given as y5. G of y5 is given as z2. So x4 is mapped to z2. This is what the composition of G of f. This is what the output you got. So you take two functions f, g, and G circle f is given as from x to z. So what happens here? Try to understand graphically. So we are having a mapping from x to z in G circle f. So how we are going to have that mapping? In between we are having a y value that is having a mapping in x and z, means it is forming a relation with x and z. It is forming a link between this x1 and z1. Those operations we are going to consider in G circle f. So this is what composition of functions means. Now try to understand the definition. If you have this graphical visualization, understanding the definition is very easy. Let's take f, x tends to y is a function and g, y tends to z is a function, be two functions. The composition relation G of f is, so what ordered pairs you are going to have in G circle f? X comma z. So f is from x to y and g is from y to z. So x to z, where x belongs to set x, z belongs to set z, and there exists y. In between you should have a y. That y belongs to set y and y is equal to f of x. It is forming a link between the x and z. And z is equal to g of y. If it is satisfied these two conditions, so we are going to take that x and z ordered pairs in G composition f. So that is what the definition is called, the composition of function, or we call it as relative product of functions. So this is what the definition of composition of functions. Hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.